For a while I've been wanting to make a robot quadruped, probably since I saw Boston Dynamics' Spot for the first time. Anyway, this project probably won't be as exciting as my previous ones. I'll be keeping the videos pretty open and there'll probably be in a few parts. Don't think it needs any more intro than that. I want a robot dog. So there's a few things I want to achieve with this. Firstly, it needs to be cheap. Building one of these can get expensive really quickly. And then I want some sort of mechanical compliance in the robot, like MIT's Cheetah Cub, just to help with the robot stability. In terms of size, it should probably be about this big. Seems about right. That's all the hardware stuff. The software I'll deal with later, and it will probably be more work than actually building it, but that's a problem for future me. Bear in mind, I've got no idea what I'm doing, but let's get started with the build. I'm going to be using these servos, which have a stall torque of about 11 kg/cm. That will affect how heavy the quadruped will be, and therefore how big it will be. So when trotting at one time, there can be just two legs supporting the robot's weight. So looking at the lower leg portion of just this one leg, assuming that the length of it is around 10 cm, and the servo has a stall torque of 11 kg/cm, that gives us a total mass of 2.2 kg, which we need to stay underneath as our target. So in that diagram, the servo was placed to the knee joint, which isn't ideal as having weight further from the hip joint increases the whole leg's moment of inertia. The common thing to do is to place the actuator at the hip joint and then to drive the lower leg with a belt or something. However, in this case, I want to use a mechanical linkage, which is probably best demonstrated with Lego. So the upper leg is controlled here, the lower leg is controlled at the hip joint through this linkage. The link can have some sort of shock absorber thing like here, which just adds some compliance. Now I'm going to model this in a less Lego-y way. So I've been modelling for a while now, and here's what I've come up with. Looking at the assembly, you can see where the servos are placed and how the linkage works. Now before printing out the whole thing, I like to print out small sections where I'm not quite sure if I've got the sizing right on, like for example where the servo slot in, just so I'm more confident when I print it and so I don't have to go back and print the whole thing again. I've already done that and they all fit well, so I'm all good to go ahead with a final print and assembly. And now I've got a leg. So along with this ridges spoke, I also printed out 3 versions of a compliant link, each one with different levels of elasticity, just so I can see which one works best. So now I just need a frame to test this on. And here is the frame I used for my spider robot, which I still have for some reason. It just needs a little bit of modification and then it should be good to use. And there we go. I've done all the electronics and stuff in the background, so let's just see it move. So here's the upper leg moving on its own. And now just the lower leg. And now here's both of them moving together. Now I've taken it off of there and put it on this hinge stand so I can see how well it supports its own weight. I tried out the shock absorbing links, however trying each one, none of them were quite strong enough for it even to hold up its own weight. So I've actually put 2 on in parallel, which is a bit clunky, but it seems to be working. Let's just give it a go. So it looks to be working alright. You can see it also has some nice compliance with that spring, which is good. However, there's a lot to do for next video. I want the hardware to be pretty much complete. I want to start to be thinking about inverse kinematics and things like that. Maybe in the video after that, I'll be in a position where I can start thinking about making it walk. Anyway, let me know what you thought of this. I know it's a bit different to what I usually do. Thanks for watching, and I'll see you next time.